Have you ever been interested in integrating static code analysis for your infrastructure as code in a CI/CD pipeline? Well, hopefully that isn't all gobbledygook to you, and that's what we're going to cover in this video. What's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesdays. It's actually Wednesday. Sorry about that. So I got a little tied up this week. Couldn't get this video out on Tuesday like I originally intended, and also I'll struggle with Azure DevOps, which is kind of the topic of what we're going to be talking about today. Before I get into that, just two quick things. Number one, I have a Terraform certification guide that I wrote with Aidan Ermy. It's in the process of being updated for Terraform 1.0. If that's of interest to you, check out the link down in the description. He's going to come up again, good old Aidan, because he kind of helped me out, even though he didn't realize it, helped me out with this video. And secondly, if you're a potential sponsor, if you're a vendor who thinks that your product might benefit from being featured on Terraform Tuesday, hey, I am open to the idea. So please reach out. You can do it via Twitter, Ned1313. My DMs are open. Let me know if that's of interest to you. I'm open to doing like a early ad at the beginning of a video, or also just a full-blown sponsored video if it's a product that I think is awesome and want to make the world a little more aware of. So without out of the way, let's talk about the topic at hand, which is using Checkov from Bridge Crew to analyze your infrastructure as code. I'm not going to lie, this has been requested by several people, so hopefully this video meets up to your expectations. We are going to be using Checkov, and we're going to integrate it into an existing project that I've been working on, which is developing a full Azure DevOps pipeline for the checking and deployment of infrastructure as code with Terraform. That's a project that has taken up 2 videos already, so this will be the 3rd video in the series. So I'll throw a card up there that links to the previous one so you can see what I've done so far. Basically, what we have at this point is a Azure DevOps pipeline that's pulling in code from a GitHub repository. And when new check-ins happen, it kicks off the pipeline. That's the trigger, is when code gets committed to the main branch. That causes a trigger, which has the pipeline run. And right now, all it does is, it validates that the Terraform code is valid. It then runs an init and a plan, and then it waits for someone to approve the plan before it goes to the apply stage. So that's what it does today. And what I'd like to do is add some static code analysis on top of validating that my syntax is correct. So that's the idea. That's the core concept. So let's get into what Checkov is from Bridge Crew and how it's going to be integrated into my pipeline. Checkov is a static code analysis tool for infrastructure as code. And it isn't just for Terraform. It can analyze CloudFormation, ARM templates, and other formats that are out there. And it has a bunch of built-in policies that it's checking for by default. So if you just run it without telling it which policies to run, it's going to run through the full battery of policies that it has and see if any of those apply to your infrastructure as code. If they do, then it's going to check whether or not the code matches up to the expectation that's in that policy. If they don't match, then the test fails, and there's something you might want to fix in your code. Or maybe you'll say, no, it's okay, I know about that, and I'm going to add an exception there for that one policy. You can also write your own policies. The policies can be in Python or in YAML, and they'll define something custom about the code. I'm looking for this resource, and it should never be configured this way. And that's something you could add in as a custom policy on top of all the existing policies that they have. So that's the basic idea. Now, the other thing to call out here is this is static code analysis, which actually lines up pretty well with infrastructure as code, since we're not trying to dynamically run an application and then test everything about that application. Infrastructure as code is generally static in nature until you send it off to the API of whatever cloud provider you're using. So static code analysis tools actually work really well. And there's 2 places you can do the static code analysis. You can do it against the Terraform code itself. You can also run it against the plan. If you convert the plan into a JSON file, then Checkov can go through that JSON file and validate that everything is cool. So that's what we want to do. There's two goals in this project. First, when a new version of the code is committed to main, I want Checkov to run through that Terraform configuration and tell me if anything in it violates the conditions. Now, there's a little caveat here because I'm going to be using some modules. So I actually want to initialize Terraform first so that all my modules are loaded. And then I want to run the static code analysis against both my code and also any code that's in the modules. Because although I'm getting these modules from a registry that I might trust, who knows what they've changed in the meantime. So I want to make sure those modules are living up to best practices as well. So that's one place where I want to run Checkov. And then I want to go through this standard Terraform plan process and produce a plan file, and then run Checkov against that plan file and make that part of my review process. And once everything looks good, I will approve the change and it will go through to the apply stage. So that's where we want to insert Checkov into our pipeline. So that's the central idea. That's what we're going to be doing in the demonstration. So let's head over to Visual Studio Code. I'll walk you through where I'm adding it in the code, and then we can actually kick off the pipeline and check that out as well. All right. Here we are in Visual Studio Code. I've got the files open on the left. You'll note that the date of the folder is 2021-06-22-ADO. That's for Azure DevOps. That's the pipeline we're going to be using. And it is yesterday's date in terms of when I'm recording this, because like I said, I thought I was going to get this recorded yesterday, and then things happened. Life happens. So and that's why the date's a little bit off. But anyway, that's what the code we're going to be using. If you're looking for these files, you can always find them on my GitHub repository. It's called Terraform Tuesdays. Pretty easy to find. And let's get into the code itself. We've got two directories here. We've got a setup directory and a VNet directory. We're not worried about the setup directory. That was used entirely for setting up this entire pipeline automagically and all of the resources that it uses. So we're not going to get into that too much. Let's instead focus on the VNet contents. We've got a main.tf file. That's the thing that's actually going through the pipeline to be checked and then deployed. And then we have our Azure pipelines.yaml file. That's the file that actually defines our pipeline. So let's open up the pipeline file first and take a look at what's in there. So I'll go ahead and open that, and let's hide the terminal because that's just taking up room. We don't need that. Let's go all the way up to the top of the pipeline. Now, as I said before, the trigger for this is that a change happens on the main branch, and it includes the path for today's files. I had to alter this because I made a copy of the previous version. All right, but that's not really important. Another cool thing that I discovered in my digging process, I was using a task to install Terraform as part of the beginning of each stage in my pipeline. And you don't need to do that because the Ubuntu image for the hosted runner or hosted agent on Azure DevOps already has Terraform 1, well, the latest version of Terraform installed. Isn't that nice? So we can totally skip that. It does not, however, have Checkov installed. So my first stage is validate. Validate does two things. It uses Terraform validate to do analysis of the code and make sure that it's valid Terraform. And now I'm also going to add in installing Checkov and running Checkov against those same files. So in our steps, one of the steps is to run a bash script that uses pip to install Checkov. And it's really just that simple. You just run a bash command and it installs Checkov. So we have that added into our pipeline in our validate stage. Then in the next step, we have to download some Azure Key Vault secrets. These are secrets that I'm using as part of my pipeline. I covered that in the previous video, so if you're wondering how Azure Key Vault is being used, go back to that video and check it out. Scrolling down a little bit more, we're going to initialize Terraform, in part because we want to download the modules so we can do analysis of those modules as well as the code that's already there. Scrolling down a little bit more, we get into the validate command. So we're simply running Terraform validate against the working directory where our configuration is. And then lastly, we get to our verifying module files with Checkov. So you can see I've done this as a bash task, and we're simply running Checkov, and then we're pointing it at the directory that has our files. And I'm first going to verify the module files that have been downloaded. So you can see I'm pointing it at the directory vnet/.terraform. That's where all the modules are going to be after we run Terraform in it. You can also see that I am skipping some of the policy checks here, the ones that have to do with Docker. If you know anything about the way that modules are published, when you download the module, you're really downloading basically a GitHub repository. You're kind of like cloning it. And in that clone is going to be a Docker file and some other things. Those don't impact how the module is used by Terraform, but they may fail some of the checks for Checkov. So I'm doing skip check CKV_Docker_star, which means all of the Docker checks are skipped because we don't care about those. And then I'm doing the output to a JUnit XML file. And hat tip to Aiden Ermy for this one. This is awesome. The reason we're doing this is we're going to output the file, if we scroll all the way over, to a file called Checkov module report. And then what are we going to do with that file? Well, if we scroll back here, the next step in our pipeline is to publish the test results of our module test. And that is using the task publish test results too. So this is going to show up in the testing in our Azure DevOps pipeline, whether or not it was successful. And it has the whole report in there of what happened. That's kind of useful. Now that we've checked our module files, scroll down a little bit more and we are going to verify the main files with Checkov. So again, we're going to do a bash task. We're going to run Checkov -- directory and point it at the VNet directory itself this time, not the .terraform directory. We'll do the same output to a JUnit XML file. And then if we scroll down a little bit more, we'll publish those test results for the root module using the JUnit format. And this will happen whether it is successful or it failed. So that's important. We're going to publish the test results whether or not the test succeeded or failed. All right, so that's everything that needs to happen in the validate stage. If the tests with Checkov fail, it's going to stop right there. It's not going to move any further. Test failed. Now, if it does succeed, it'll move to the next stage, which is plan. So let's scroll down to plan. In our plan stage is going to install Checkov just like we did before. And this is because you're going to get it's a new stage. We're going to get a new VM image out of the pool. It's not going to have Checkov installed. So we have to do that again. And we also have to do the same thing with Azure Key Vault. And we have to initialize Terraform. So we're going to do that. And then we're going to run a Terraform plan. And under the command options for the Terraform plan task, we are going to specify we want to output the file to the working directory and call it main.tf plan. So now we have our TF plan file. Now we want to verify that plan with Checkov. And the way that we do that is we're going to run a bash script again. This time we're going to go to the directory where that TF plan file is. And I want to make sure I'm in the right directory, so I have an ls here. This is the thing that I was really struggling with last night when I was trying to get this all working. And now we can run Terraform show -json and give it the main.tf plan file, and it will convert. Well, it won't convert. It'll output it as JSON, and then we can just direct that to a file, main.json. Now we have our plan in JSON, and we can use Checkov again to scan the file main.json and output that to the JUnit XML format. Awesome. Now we scroll down a little bit, we see I have to include a bunch of environment variables here. And that's because Terraform show requires basically that you have Terraform initialized and that it has access to everything you use to initialize Terraform. That's another thing that I stumbled over pretty hard, because I don't use Terraform show all that often. And in this automated fashion, you needed to be in the right directory and have the right environment variables. So I figured that all out so you don't have to. And then lastly, we're going to publish our test results for the plan, whether it succeeds or fails. Now it will move to the next stage, which is approve, and it's a manual approval. The approver can now go back, look at the test results, and then make a determination of whether to move forward with the deployment or stop right there. So that's everything that's in the pipeline. Let's take a look at our main.tf file. In the main.tf file, we're deploying an Azure VNet, and we've used this module before, so no big surprises there. But I've added an additional resource in here, and that is a security group. And I've added a security rule inside the security group that allows SSH from anywhere. So Checkov isn't going to like that. It has a check that says do not allow SSH from anywhere. So this is going to violate, and our first test should fail. And then I can make a change here so that it will pass. So I already have this queued up as ready to commit. So I'll go ahead and commit this change with this new security rule. So I'll just add sec rule here. I'll commit it, and then I'm going to push it. There we go. It's now been pushed up to the GitHub repository, and that should kick off a run of the pipeline. So let's jump over to a browser. And here is the Azure DevOps project that I'm talking about. Let's go to pipelines, and we should have a pipeline currently running. We sure do. It's my tacos pipeline. And you saw that the commit was sec rule. So this is the commit that we just had. Let's go ahead and watch the progress in the validate stage. So let's expand this out, and we can see it's in the process of checking out the code. Now it's going to install Checkov. This might take a moment or two, but after that, it will go through the rest of the stages, and it should fail on one of these stages. So I'm going to speed up the video a little bit so we don't have to sit through the entire run, and we'll see what happens once it gets to the publish Checkov root test results. All right, we've reached the end of the validate stage. It's doing its post-job completion, but we can go back and look at this failed test here, verify root module. So first, actually, let's go up to the verify modules with Checkov. This is where it verified the modules, and there's no output here, which implies that nothing was wrong. It was okay, and it sent all its output to that JUnit XML file. Now let's move to the verify root module, and we can see there was one error here, but we don't see the output because that was sent to our testing. So let's go back to the view of this pipeline run in general, and you'll see there's a tests tab here. And if we hit our tests, we can see that there were 3 total tests, and one of the tests failed, and it tells us what the test is. It says that we failed the check, ensure that SSH access is restricted from the internet. We failed that check, and we knew we were going to fail that check. That was very much intentional. If you want to see all of the tests that were run, what we can do is change the filter here to passed and passed on rerun, so we can see all of the checks that were run. And this is kind of, there we go. It's not the greatest interface because I don't think I can slide this at all. But as you can see, Checkov ran other checks that applied to what was in our configuration, and only one of those checks failed. But it did in fact fail. So now let's alter our configuration so that this check does not fail. All right, we're back in Visual Studio Code, and all I'm going to do is simply change the access from allow to deny, and now it'll deny that traffic from anywhere. We'll go ahead and save that change, and then that is a new commit. So remove access will be my commit message, and we'll go ahead and push that, and that will kick off a new pipeline run. So let's go back over to the browser and go back to our pipelines, and we should see a new pipeline kickoff in a moment. Go ahead and click on it again. Sometimes it takes a moment. There we go. It's kicked over, and we can see the commit message is remove access. So this is the new one that is running. And if we go into the stages, we can see it's in validate. Now, validate, all the stages should pass because we removed the offending rule. So go ahead and pause it now and resume when the validate run is complete. Okay, our validate stage has completed successfully. The portion that we were failing before, this verify root module, this time it exited with a 0, so all the tests passed on that. We can see those in the published tests in a moment, but let's scroll down and take a look at what's going on with plan. So plan is going through its steps now. It's going to install Checkov, go through the initialization and plan for Terraform, and then it's going to use Checkov to verify the plan and send that to our test results. So this is also going to take a moment. So why don't I pause things and we'll resume when the plan stage is complete. Okay, our plan stage completed successfully. And if we go to the verify plan with Checkov task, it looks like that also completed without any errors. So if we go back to the main pipeline view, well, too far, go into here and go to tests, we can see it's got 6 passed and 0 failed. It performed 3 checks when it went through the initial analysis of our root code, and then it performed those same 3 checks when it did the analysis of our plan. If we go here and check on include passed in our view, we can see there's the Checkov root scan and all 3 tests passed. And then there's the Checkov plan scan and all 3 tests passed for that. So if I were the reviewer for this and wanted to make sure that I wasn't violating anything by policy, I could see that everything is good. The other thing I discovered is that there is now a Terraform plan a Terraform plan option for the Terraform plan task that will send that Terraform plan output so you can review it here in a nice screen as opposed to trying to review it in the logs. And so this is going to tell us exactly what it plans to do. It plans to add 1. And actually, if we go to summary, we can see it tells us that it's going to create 1 resource and that it's waiting for our manual validation. That's what we want to do. Well, everything looks good to me, so I'll go ahead and click on review and say, looks good. All right, and then click on resume, and now our pipeline will move to the last stage in the pipeline. And if we want to take a look at that, we can see down here, apply is not started, but it's about to. It's in the process of starting, and that apply process well, it's not going to change anything about the VNet because that already existed, but it will add that security group with the rule that denies SSH. So that is using Checkov to check the code, both of the main code itself, and then also check the plan generated by Terraform. Okay, so we successfully integrated Checkov into our Azure DevOps pipeline, and you can absolutely do this too. If you are walking through this process, it was really not that hard to get Checkov working, and I definitely am going to include a link to Aidan Ermey's post about how he went about it. He actually ended up using a Docker container to run the checks as opposed to installing it on the hosted agent. You could also create your own agent that has Checkov pre-installed, and that would probably speed up the process a little bit. Now, let's talk about future plans for what I'm going to do in the next revision of my DevOps pipeline. And there's one big thing that I want to do. I'd really like to run the validation and static code analysis when new code is checked in to a branch and then a pull request is created to merge to main. That's when I think I would want to validate the code as a sanity check before I accepted the merge, and also run Checkov against it before I accepted the merge. So that's where I want to run that piece of code. And then I want a totally separate piece of code when the merge is actually accepted into main. I want a separate pipeline that then walks through checking the Terraform plan with Checkov and doing the application of actually deploying out the infrastructure from the merge. So I want to split it into 2 pipelines, basically. So that is one thing that I want to do. And the other thing I want to do is stash the output file somewhere. If I want to do a manual approval and I want to look at the plan before I approve it, I want that plan.tf file to be available to me so I can ensure that whatever's run by apply is codified in that TF plan file and not just apply running as an auto approve. So those are the 2 big improvements that I want to do in the next video dealing with Azure DevOps pipelines with Terraform. All right, that's going to do it for me for today. Hey, big thanks to Aidan Ermey for that blog post. That actually helped me tremendously when I was trying to work through this. Shout out to Bridge Crew for creating an awesome tool that works really well. It was so intuitive. I was like, I must be missing something because this is too easy. I mean, Azure DevOps made it a little more difficult, but the Checkov tool itself was actually really easy to use. So good job on both of that. And hey, thanks to you for watching. I do appreciate it. If you want to subscribe to the channel, I love it. I love you. Thank you so much for subscribing. If you want to like and share with a friend, I appreciate that too. If you're interested in supporting the show in some way, I do have a Patreon, so you can sign up for that and you will get early access to videos as well as a weekly newsletter. And hey, if you're a vendor out there that wants to sponsor an episode, reach out to me. I'm available. That'll do it for me for today. Until next time, stay healthy, stay safe out there. Bye for now. I swear this is the last thing I'm going to show from my parents' garage that I found, but this is a ridiculously funny book. It's really, really good. It absolutely holds up. And some of the people in here are, I mean, they're pretty famous now. You might recognize at least one of them from Brooklyn Nine-Nine. But yeah, just an awesome group, state by state with the state. It's very fictional. It's very silly. And I've been enjoying rereading it. So, hey, are you enjoying rereading a book you found in your parents' attic? Let me know about it down in the comments. See ya.